Hello everyone, welcome back to your YouTube channel AgriAddict. I'm your mentor for this crash course on horticulture. My name is Deepthi. I have been graduated in horticulture from Acharya Engineering Agriculture University, Hyderabad. I have done my master's from GKVK, University of Agriculture Science at Bangalore in the Department of Fruit Science. I have also finished my PhD from Dr. Paisar Horticulture University, Tadapalligudem, Andhra Pradesh. During my academic journey, I have secured 21st rank in ICAR AIEEA PG entrance exam during 2005. I also cleared my ASRB net during 2008 and 9. Today, we are going to start our discussion on the topic post-harvest management of horticulture crops. Introduction. We all know that horticulture plays a significant role in the Indian agriculture scenario. So this horticulture contributes to GDP, that is around 30.4% from cultivable land area of 13.1%. So it directly contributes to the national GDP. Then India being the second largest producer of fruits and vegetables. We all know that India ranks second in the world production of fruits and vegetables, which accounts for nearly 110 million tons of fruits and 212 million tons of vegetables respectively. Then being rich source of carbohydrates, minerals, vitamins, and dietary fibers, these fruits and vegetables constitute an important part in our daily diet. So we all have fruits and vegetables on a daily basis, right? Then not only these fruits form the major diet, they also provide variety in taste, interest, and also aesthetic appeal. So for the fruits and vegetables have varied tastes when compared to agriculture crops. Likewise, the interest cooking culinary purposes, the menu is also very much different. Dishes prepared from these fruits and vegetables is also very different, and the aesthetic appeal, there are different colors can be obtained from different fruits, so and some of the vegetables. So when compared to agriculture crops, this is a interesting sector, horticulture. So likewise, the people also prefer eating fruits and vegetables nowadays because of the health conscious and all. Then, but a considerable amount of fruits and vegetables produced in India is lost. How? Because due to improper post-harvest operations. So after the harvest, they are not taken care properly. That is the reason why losses have been incurred. As a result, there is a considerable gap between the production as well as availability to the consumer. So at the grower level, the statistics is different of fruits and vegetables compared to at the consumer level, the availability to the consumer, the statistics is different. If you grow this much of fruits and vegetables, if for example, if you see around 110 million tons of fruits is produced in the by the farmers annually in our country. But if you look at the consumer level, these 110 million tons is not being available for all the consumers, all the people who want to have them. What is the reason for that? So let us go into the details one by one. If you look, not only that losses, which have a percentage of 20 to 40%. So among all the agriculture crops or among all the crops which are being cultivated, the losses of fruits and vegetables is very high, which accounts for 20 to 40%. And if you see, a small fraction of fruits and vegetables is utilized for processing, that is value addition. For value addition, for making into different products, the production under the production of fruits and vegetables, less than 1% is being utilized for value addition of fruits and vegetables. And if you see for export, it is around 2% in case of vegetables and 0.5% in case of fruits. So even for export purpose also is very less when compared to other countries. Then if you see 10 to 15% of fruits and vegetables shrivel and decay. So because fruits and vegetables are highly perishable in nature, which have more than 70% of moisture in them. So that is the reason why they shrivel and decay very fast when compared to agriculture crops, lowering their market value and consumer acceptability. This is also one reason why the availability, net availability is less when compared to the production. Then we should aim to minimize these losses by increasing their supply without bringing the additional land under cultivation, because land is a very important resource. We cannot increase their cultivation as such. Thereby, we have to minimize the losses. So, on the other hand, if you look, the losses should be minimized. If there is the same piece of land, the losses should be minimized for and the productivity can be increased. So this is a chart which shows the possible causes for post-harvest losses of fruits and vegetables. So they can be divided into primary causes, these biological or biotic causes, and environmental causes, abiotic causes. Under the primary causes, the losses can be incurred due to careless handling during harvesting, packing, transportation, and storage as well. And also the marketing. During the marketing, the post-harvest handling operations, the fruits are not taken care properly. So that is the reason why the loss can be incurred. However, if you see the biotic causes, that is within the fruits and vegetables, the horticulture commodity itself, the respiration, transpiration, ethylene evolution, and infestation with pests and diseases. This also one reason for post-harvest losses. Then if you see environmental causes, abiotic factors like after harvest, so the post-harvest temperature, then relative humidity, atmospheric condition, and light, all this put together are the main causes for post-harvest losses of fruits, which accounts for about 20 to 40%. Fruits and vegetables in our country, the losses is for about 20 to 40%. So one should know about the all the reasons which will cause the major post-harvest losses from fruits and vegetables. Then only they can reduce or eliminate these losses, thereby increasing the availability of the commodities, fruits and vegetables to the consumers. And if we see this table, which shows the group of fruits and vegetables along with their examples, and also the principal causes for post-harvest losses and poor quality. If you see the root vegetables like carrot, beets, onions, the tubers as well as bulbs, the main cause for loss is mechanical injuries, and also shriveling, rotting, sprouting, and decay. Then improper curing also. So after harvest, these root vegetables should be cured properly. Otherwise, they may tend to die, senescence. So they may not fetch a good market price. So that is a major cost. So nobody will purchase them. So they are definitely go to the bin. Then among the leafy vegetables and pole crops, if you see, wilting is the main cause for loss, then yellowing, mechanical injuries, and some of them decay. Then flower vegetables like broccoli and cauliflower, yellowing and discoloration of the head, then or the curd, then decay, then mechanical injuries. Most of them are mechanical injuries in most of the because of the improper handling during harvest as well as post-harvest. Then immature fruits and vegetables like cucumbers, squashes, okra, eggplant, all these are shriveling, the water loss. The transpiration is more than bruising and other mechanical injuries. Sometimes chilling injuries during storage also may cause decay. Then mature fruits and vegetables like tomato, melons, then bananas, mangoes, apples, and all these stone fruits, climatic as well as non-climatic fruits. The main cause for loss are mechanical injuries like bruising, then overripeness, excessive softening. So the right stage of maturity, at right stage of maturity only they have to be harvested. Then only they can extend the shelf life. We can prolong the shelf life. If they're harvested too late, then we can observe the decay. Then water loss, chilling injury, and the composition changes within the commodities are also the principal losses of post-harvest losses of fruits and vegetables, which aims for poor quality. Then let us understand the discipline post-harvest technology. As we have discussed in the first lecture, post-harvest technology is the fifth discipline, most important discipline of horticulture. So it is a branch of horticulture that deals with the operations right from harvesting or even the pre-harvest stages. So not only after harvesting, the pre-harvest stages which influence the quality and the quantity stage of the fruits and vegetables or the commodities, horticulture commodities that reaches the consumer either in fresh form or in processed form. So they may be either fresh fruits or vegetables, or they're processed into various products like juice, jam, ketchup, pickle, and all. And utilization of the waste, like pomace, peel, seed, all the byproducts, and how these byproducts are utilized in a profitable manner. So, manufacturing of fermented beverages, color extraction, pectic extraction, all these are secondary processing. So these all these put together, we call them as a branch of post-harvest technology. It is a branch of horticulture. It deals with right from harvesting, pre-harvest stages, and the fresh form and processed form, and also the utilization of the byproducts. So all this put together, we can call it as the study. We can call it as post-harvest technology, and the technologies related to this, the science related to this, we can call it as post-harvest technology. And interestingly, we can observe that it deals with two major subdivisions like management as well as preservation. So the first one is post-harvest management, that is the handling of the produce or the commodities, horticulture commodities after harvest. And then the other one is value addition, preservation, them into different products. So this post-harvest technology has two different disciplines like handling, post-harvest management, as well as preservation or value addition. Then importance of this post-harvest technology. So what is the need? What is the scope? First, in reduction of post-harvest losses. Before, we have seen different types of post-harvest losses for this horticulture commodities. So why we need to go for post-harvest technology means, first, to reduce these post-harvest losses, to make use to the consumer by in an alternative way. By reduction is possible by in an alternative way, by increasing the production of agriculture and horticulture crops and reducing the post-harvest losses in the same piece of land. Then reduction of cost of production. So the cost of production, post-production, like packaging, storage, transportation, marketing, and even the distribution and all this can be reduced in the study of this post-harvest technology. Then reducing malnutrition, so sufficient food for all, and extend the season of availability in a particular commodity. So economic loss reduction. If you see, the economic losses at the grower level are more during marketing and the consumer end when compared to the from grower to the consumer end. The economic losses is also more because of the post-harvest losses. So the farmer may not get the price which he is quoting. So if the quality is poor, then he may get less value. So that is the reason why the post-harvest technology aims for economic loss reduction. It also aims for availability year round. So throughout the year, some of the commodities which are season based, like mango, and some of them are seasonal based. For that, for availability throughout the year, they are made into different value addition. The value addition of the fruits can be given into different products, and some commodities like banana and mango, so they are almost present in all the places of the country. Then exports also is possible with this study. Then employment generation. So we know that either directly or indirectly, the horticulture sector and the food processing industry rank first in terms of employment generation. Then export earnings. So we can go for exporting of either fresh or processed horticulture commodities, the fruits and vegetables. Can be processed to both, which extracts valuable foreign exchange. The foreign exchange income returns are higher can you export for other countries. Then it also post-harvest technology also aims for defense as well as astronaut requirements, which have special requirements for the ready to eat as well as high energy, low volume food. So all this can be the R&D, research and development can be taken care. The post-harvest technology R&D can be taken care for this for their requirement. Then likewise, infant and sports preparations. So special people, not normal people, special people like the defense astronauts, sports personnel. So all these defense personnel and all, for all of them. So it is important even for the little kids or infants also, to meet the specific nutritional requirement of the body. They can be made into different products with the help of this post-harvest technology. So today we are mainly concerned about the post-harvest technology sub-discipline, that is post-harvest management or the handling, post-harvest handling of horticulture commodities, especially the fruits and vegetables. We are concerned with the fruits and vegetables. So let us understand what is meant by harvest. A harvest is a specific and single deliberate action to separate the foodstuff with or without non-edible portion from its growing medium. So for its growth medium or from the mother plant, we can say that it is the deliberate action. So harvesting is the removal or the separation of the foodstuff or the plant which contains the storage organ, the main it stores food. So the food which is stored, the part which is stored food, either with or without non-edible, without edible portion. So not only the food which is consumed by our buyers, and also the inedible portion is also separated from its growth medium or the mother plant. Example, if you see the plucking of fruits and vegetables, it is most of them it is which is edible for us, but however in some vegetables non-edible portion is also plucked or harvested. So reaping of cereals in case of agriculture crops, in case of fisheries it is the lifting of fish. The lifting of fish from water is also called as harvesting. The lifting of tubers or roots from the soil. Likewise, plucking of leaves in case of vegetables, or uprooting the whole plant in some leafy vegetables and so on. So all this comes is termed as harvest. Then if you look, what is the definition of post-harvest? So it refers to the all succeeding actions after harvest are defined as post-harvest technique. So after harvest until it reaches to the consumer, so all the stages, different stages or the actions, we call them as post-harvest. From this period of time, all actions that enters the process of preparation for the final consumption. So the commodity, the agriculture, the horticulture commodity, the fruits and vegetables are prepared such that they reach the end, that is the consumer for the final consumption. So what are these actions, or what are these steps? Means first pre-cooling. After harvesting is first pre-cooling, then cleaning, washing, trimming and sorting, curing, grading into different according to the size, according to the color, into different categories. Then waxing them, giving chemical treatments to extend the shelf life. Then packaging them, transporting them to by various means to different regions of the country or outside the country. Then storaging, ripening in some fruits, and then distributing or marketing. So all this comes under the post-harvest management or the post-harvest handling. So if you look, I told you already that fruits and vegetables are highly perishable in nature, which accounts for more than 70 to 75% of moisture in them. That is the reason why they are highly perishable. So they tend to lose in weight. And also infestation with pests and diseases are the main causes for loss or decay for these fruits and vegetables. That is the reason why they are called highly perishable in nature. And unless great care is taken in the harvesting, handling and transportation. So these products are usually, we can term them as handled with care. So great care has to be taken in harvesting, handling and transportation until they reach to the consumer in the market. So they soon decay and become unfit for human consumption. The process of decay being accelerated, a poorly harvested and handled produce is placed in storage for any length of time. So they should be taken care of very well, and they have to be handled with great care, such that the produce is to be made fit for consumption, so for any length of time. So the purpose is to extend the shelf life, and the fruit or vegetable should look like as if it has harvested yesterday or day before yesterday. So that is the reason why we have different steps for making them fit for consumption. Then where and how to handle this horticulture produce? It has been observed that improper handling of fruits and vegetables is a major cause for deterioration and post-harvest losses. So in order to minimize these losses, the produce should be handled carefully during the entire supply chain. So handling at each stage, as I've told you, the different stages in the previous slide, like from pre-cooling to storage, then trimming, grading, and all this comes. So at every stage, the commodity should be handled properly, such that it should not undergo any mechanical injury. But within the plant, within the commodity, some damage also occurs. So that is also taken care of. Then produce handling plays an important role in the following stages of the supply chain. So what happens, the supply chain, post-harvest supply chain is, at the time of the harvest, we need to be careful at the field level. First, these both considered at the field level. Then after, at the time of loading and unloading, the commodities into the for road transport into the trucks. At the time of transportation, then at wholesale market, at retail market, and even at the consumer end. So all this need to be taken care of. Let us understand the flow chart for post-harvest handling operations of the horticulture produce. The various steps here you can see. First, initially, it is the harvesting of the produce or the fruit and vegetable. Then comes to pre-cooling. So they have to be, we call it as farm heat. So fruits and vegetables immediately after harvesting, they possess the heat where they are harvested. So at the farm level, this is called farm heat or the latent heat. So these need to be cooled first. Otherwise, for commodities will, if you not cool them initially, the commodities will decay at a very faster rate. So that is the reason why we have to pre-cool them initially to remove the heat. The harvest heat, we call it as farm heat or harvest heat. Then after that, we should sort them for the diseased or any mix is there for apart from fruits and vegetables, any others, the leaves, and also some of the non-edible commodities should be removed. Then cleaning them and trimming if required for vegetables. Then washing them. Next step is we can give chemical treatments in order to increase the firmness. Then curing in case of tubers and bulbs. Then waxing them to reduce the post-harvest losses from within, or like rate of respiration and rate of transpiration can be reduced by a process called waxing. Then sizing and grading into different grades according to the size and color. Then packaging them, then transporting them by air, water, and also by road transport. Then they are transported to the wholesalers first. There again, repacking, resizing, and resorting is done. Then during this process also, some of the fruits and vegetables decay. So those has to be removed first. Then again, they are transported to the retailer shops as well as directly for the consumer end. These are the pictures which shows the different post-harvest handling steps, like harvesting, So the field level, then packaging, sorting, grading, and all being done at the farm level. If they have cold chambers, some of the fruits are not marketed as such. So they are stored for some time. After that, they are transported. Some are transported directly. Some will be stored and then again transported. Then marketing to the retail shops. Then the consumer will buy from them. So these are the different stages. The fruit and vegetable pass till it reaches to the people who eat them. So let us understand fruit and vegetables are alive after harvest. Yes, they are under live conditions only, even though they are removed from the mother plant or removed from the soil. They are still alive, if we can call. Why? Because they respire by taking oxygen and giving off carbon dioxide like us. So respiration is also being observed in the fruits and vegetables even after harvest. And heat, they also release heat. And then they transfer. So they release heat. That is the reason why we are pre-cooling them. And sometimes we are cold storing. Chilling requirement is given for them such that they extend the shelf life. They will not decay normally. So we can extend the life of the fruits and vegetables. That is the reason why they are kept under cold conditions. They also transpire. They lose water. Not only with the process of respiration, they tend to lose water, and they also transpire. Most of the leafy vegetables will transpire fast when compared to other fruits and vegetables. While attached to the plants, if you look, losses due to transpiration and respiration are replaced by flow of sap. So that is the reason why the fruits look fresh before harvest. As and when we remove them from the plants or the trees, they started respiring more, which contain water, photosynthesis and minerals. These functions continue even after harvest. And since the produce is now removed from its normal source of water, photosynthesis and minerals, the produce entirely depend on their own for their food reserves and moisture content. So if the plants are intact, if the fruits and vegetables are intact to the plants or trees, they are replaced by the flow of slab. The xylem and phloem, they have exchange of this water, photosynthesis and minerals. But however, if we cut them or if we harvest them, if we remove them from the plant or tree, they depend upon their own food reserves. So the fruits are the reserves of the carbohydrates, proteins and all this. The seed will utilize these food reserves for its development. The embryo will take this and the seed will put forth the germination, and thereby new plant arises. So that is the reason why plants store food reserves in the form of fruits. So then if we remove them, they utilize these food reserves, and then decay will so on. The loss of weight is being observed. So they shrivel. So the fruits itself undergo certain biochemical changes. Then therefore these losses are repairable substrates and moisture are not made up. So the deterioration starts, the decay or the deterioration commences hence. That is the reason why they are called perishables. The embryo or the fruit itself start respiring all the biochemical changes which observed when the fruit is intact to the plant, or when the fruit is removed from the plant, or if it is harvested also, all this set of biochemical changes will go on. That is the reason why they are called as they are alive after harvest. So you can see here the picture. If you look the fresh produce after harvest, if it is depicted in the form of a human, or if the fruit is depicted as a human, you can see even as and when the fruit is harvested from the tree or the plant, it is still alive. So it is still happy for some hours. After then it starts breathing. Then it releases heat. Then it loses moisture. Thereby, it loses moisture. So it reduces in weight. So it releases moisture, it reduces weight, it loses its turgidity or the firmness. Then it releases heat. So because of that heat, again the trigger, it releases more water, more, it loses more water, more moisture. So this is a catalytic in property. So even the ethylene evolution is also more. Thereafter, again taking back that ethylene, it will decay more. So then finally it can get sick, infestation with pests and diseases, post-harvest pests and diseases, or post-harvest diseases, we can say that, and ultimately it can die. So these are the various steps. If you look, the fruit will undergo, if we are taking care of these processes. So if we reduce these processes, so if the fruits and vegetables, they release heat, if we put them under low temperatures or chilling or freezing temperatures, we can achieve, or we can extend the freshness of the fruit, and we can lock the moisture loss. That is the reason why we can extend the shelf life of the fruits, or we can make the fruit not to die so early. So it will dry little bit later. So that is the pictorial description of the produce which undergoes these many changes until it dies. Then this is the table which shows the biochemical changes that occur during the ripening of the fruit. Before I was telling you, the biochemical changes or the events that occur within the fruit are seed maturation. So the embryo, the zygote, which is formed, which matures into the seed. So the first it happens. Then after that, changes in the pigmentation or the color. The quality parameters is color here. Degradation of chlorophyll. First, the green color, loss of green color. Then unmasking of the existing pigments. Then synthesis of carotenoids, orange color in some fruits and vegetables. Then synthesis of anthocyanins, purple color in some fruits and vegetables. Then next, these are the quality parameters, color changes. Then the textural changes also are noticed. That is nothing but softening of the commodity. That because of the changes in the pectin compositions, the changes in the cell wall composition. So the cell wall is made up of pectin. So it loses its turgidity finally. Then hydrolysis of storage materials. Then the flavor parameter changes are because of the starch to conversion of sugars again to starch. Sometimes the reversal may also happen. Then production of the aromatic volatiles. So as and when the fruit started ripening, so it matures. After that ripening, in some fruits, noticeable changes in the aroma or the flavor can be noticed. Then changes in the organic acid contents. Then in some fruits, some organic acids are more during ripening. So and then some fruit abscission takes place. Then changes in the respiration rate, changes in the ethylene synthesis rate, then tissue permeability. So that is the reason why dropping of the fruit occurs because of the fruit abscission, because of the high levels of abscisic acid content, AB. Then ripening changes will come, then softening changes will come, changes in the protein concentrations, then qualitative and quantitative changes in enzyme synthesis, development of the surface waxes, shining. This is limited to some fruits and vegetables. So this is the pictorial description of changes that occur during ripening. These we have seen the biochemical changes in the form of tabular. If you look here, these changes are mediated by enzymes, especially kinase. If you see the organic acids, in case of this is the unripe fruit, and this is the ripe fruit. So this is a process of ripening where ethylene production is more from unripe fruit to ripe fruit. The acids are becoming neutral here. Then in immature fruit, it is the starch which is broken down by amylase enzyme into sugars. Then the chlorophyll by hydrolyze into anthocyanins and carotenoids. Then pectin, with the help of this pectinases, the fruit becomes soft. Then hydrolysis also will help in the improvement of the volatile compounds or the aromatic compounds. Then if you look, all these major physiological and biochemical changes that occurs in fruits and vegetables is a change in the pattern of respiration. So rate of respiration as well as ethylene production is very much important in case of studying the post-harvest handling of or management of fruits and vegetables in horticulture. This has great importance. The respiration rate of produce is an excellent indicator of metabolic activity of the tissue, and thus it is a useful guide to the potential storage life of the produce. If the respiration rate of the fruit and vegetables is measured as their O2 consumed and CO2 evolved. So this is consumed and this is evolved during the course of the development, like maturation, ripening, and senescence period. A characteristic respiratory pattern is observed in different fruits and vegetables. So this impacts the pattern of ethylene also. So these two are very interdependable. So that is the reason why respiration rate and ethylene rate are very much important, and they act as a guide for knowing the storage life or the shelf life of the fruits and vegetables. So based upon this pattern, fruits can be classified into climateric as well as non-climateric fruits. So they exhibit a pronounced increase. Few fruits, if you look, pronounced increase in the rate of respiration, that is CO2 evolution and C2H4 evolution, that is ethylene evolution, which coincides with the phase of the ripening. Those type of fruits are called climateric fruits, and such fruits, such increase is not known. Those are called non-climateric fruits, and this group of fruit is called climateric, and the respiratory peak is called climateric peak. Let us understand this in the graphic manner. With the help of this graph, you can understand this. If you look, the growth of the fruit from cell division to cell enlargement, then cell maturation, and then ripening and senescence stages. So cell division, enlargement, which we call it as growth, and cell enlargement until maturation stage. Then thereafter we can observe the ripening stage. And this graph shows the production of ethylene, respiration rate, and also the growth. The line, this line shows the growth of the growth of fruit in place of climateric plants, and the dotted line, this continuous line shows the growth of the climateric fruits, and this dotted line shows the growth of in case of growth of fruits in case of non-climateric fruits. So here you can see the climatic produce and the non-climatic produce. So this is the straight line, this is the dotted line. You can see the fruit growth is almost same for both. So it peaks at the maturation stage. So thereupon the growth is stopped. It is almost neutral. Then if we look into the respiration rate of this climateric fruits, it increases during the ripening phase. However, if you see in case of non-climatic fruits, this is almost in the declining stage. So the respiration rate is more during the cell division and cell enlargement phase. During the fruit growth, it is almost nil. We can say that during the ripening and senescence phase in case of non-climateric fruits. Likewise, if you see the ethylene production rate in case of climateric fruits also peaks to the maximum in case of climateric fruits. But however, if you see the dotted line in case of non-climateric fruits, it is nil. There is no change during the growth, maturation, ripening, as well as senescence phase or the growth phase. So it is almost similar in all the stages. So this peak in case of respiration, carbon dioxide evolution or the ethylene evolution. So this peak during the ripening phase, which coincides with the ripening phase, we call those set of fruits as climateric fruits and the other as non-climateric fruits. So this is The set of so all these fruits, avocado, banana, pear, and apple, all these are termed as climateric fruits, which you can see here the rate of respiration release per ml carbon dioxide per kg per hour. If you see, the peak is obtained for avocado and banana to some extent, then pear and apple is almost after 30 days at 15 degrees centigrade, it shows a minimum normal rise in the respiration. So, but avocado, it shows more during 10 days only at 15 degrees centigrade. So we can say that apple is also a climateric fruit, but it shows a little evolution and it can withstand for more than 2 to 3 weeks. It can withstand, it can prolong the shelf life. So by knowing this rate of respiration and ethylene, we can extend the post-harvest shelf life or prolong the shelf life. This is helpful for studying the best temperature in which the fruit crop can be stored. Then this is a table which shows the difference between climateric fruits and non-climateric fruits. If you look, these ripen after harvest only, and these fruits do not ripe after harvest. They ripe on the plant itself. That is a major difference among the climateric and non-climateric fruits. Then the quality of the fruit also changes drastically. The characterized by softening, changes in color and sweetness. If you look at these non-climateric fruits, there is not much quality change except softening. And they do not improve the eating quality characteristics also, that sweet taste, sweetness, and also acidity, all this and all. There is a slight improvement, but on the other hand, if you see the climateric fruits are drastically, the changes are observed drastically. So as and when the ripening starts, then we can observe these fruits exhibit a peak in respiration. They do not have any peak when we compare with both the fruits. We can notice a peak in respiration or carbon dioxide evolution. Then more ethylene is produced during ripening, and less or no ethylene is produced in case of non-climateric fruits. CO2 as well as C2H4. You should remember this. These two evolution is more. They produce more. The fruits are called climateric fruits. Then a decrease in the internal organ oxygen concentration. Then low concentration of ethylene is sufficient to hasten ripening. If you want to ripen, exogenous application of ethylene may not give much difference for this non-climateric fruits. Their quality remain the same. They may not ripe. They ripe on the tree itself. Then if you look into the example, most of the fruits, tropical, all the tropical fruits are climatic in nature. Some of the temperate fruits and also most of the subtropical fruits are comes under climateric fruit category. So here you can see mango, sapota, papaya, apple. Then non-climatic fruits examples are mostly the fruits or the vegetables which are of economic importance, like bell pepper. Even tomato also comes under climatic fruits also. Because it is a fruit vegetable. We know that bell pepper is a fruit vegetable, but it is a non-climatic fruit. Then non-climatic fruit examples are you can see this cucumber, eggplant, most of the vegetables. Then you can see citrus group especially, and cherry. These are non-climatic fruits. Then pineapple, this also. Then pomegranate, then strawberry, then watermelon, all these gourds also, they comes under non-climatic group. Then this is also a table which shows the commodities, the fruits and vegetables according to their respiration rate. So the classes, different classes here are very low respiration rate group, that is less than 5 mg carbon dioxide per kg per hour. All the dried fruits and vegetables and nuts. Then low group 5 to 10. Then moderate, it is 10 to 20. The examples are apple. See here, in the graph, we can see that apple releases less amount, but the peak is seen. But however, when compared to other climatic fruits, apple releases less amount of carbon dioxide and ethylene. Then citrus fruits and all these non-climatic fruits. Then moderately, it is 10 to 12 mg per CO2 per kg per hour. We can see mango, banana, then peach, plum, and all this. High rate of respiration rate is observed. It is 20 to 40 mg per kg per hour in case of avocados. Then cauliflower, leek lettuce, and all. Then very high, it is 40 to 60 in case of Brussels sprouts, all the cool crops and some green onions, okra, etc. And extremely high is more than 60 mg CO2 per kg per hour, which is observed in case of asparagus, mushrooms, spinach, and all this. Then according to the rate of ethylene evolution, so different categories can also be divided. The fruits and vegetables can be divided into different categories, like very low, which is less than 0.1% ethylene per kg per hour is being released. The examples here are grape, cut flowers, leafy vegetables. So they release less than 1%. Then 1.1 to less than 0.1%. Then 0.1 to 1% all the vegetables, pineapple, okra, some of the non-climatic foods. Then moderate, it is 1 to 10 microns carbon dioxide. Ethylene per kg per hour is apple, apricot, kiwi fruit, papaya, peach, plum, and all. Then very high, it is more than 100 in case of sapota and passion fruit. So after knowing the different post-harvest handling techniques on the operations which are being done for the horticulture commodities for fruits and vegetables, let us understand the maturity indices of fruits and vegetables. So harvesting at the horticulture produce at the right stage of maturity is very much essential in order to maintain the quality, intrinsic quality of these commodities for maximum returns. So what is maturity? So the maturity is the stage of full development of the tissues of the fruit, only after which it will ripen. So ripening stage comes only after maturity. So before, in the previous slide, I have been showing you a graph which shows the development of the fruit. So fruit development and their stages. So the first one is cell maturation, cell division. There comes cell elongation and maturation. So these put together the cell growth of the fruit. So until maturation, upon which the fruit will not develop, only it will start ripening. So maturation and ripening. So at the maturation stage only, the fruits have to be harvested. So that is the reason why one should know at what appropriate stage of maturity or the right stage of maturity in order to get maximum returns, keeping the quality same when it is before harvest. Then what is maturation? Maturation is the stage of development leading to the attainment of physiological and horticultural maturity. So it is a fruit development stage and the attainment of the peak. So upon which there is no further growth of the fruit or vegetable. So that stage we call it as maturation. It is preceded by ripening. What are the principles of, let us understand the principles of this harvest maturity. So in order to have a peak acceptable quality of the commodity, whether it is a fruit or a vegetable, it should have a peak acceptable quality. It should gain maximum returns in the market. So it until when it reaches to the consumer. So the even when it is harvested, what quality it is possessing, it should have more quality or equivalent quality by the time it reaches to the consumer. That should be kept in mind. Then the produce should develop an acceptable flavor, color, appearance, and all this. Then the produce should have optimum shades and size and shape required by the market. Then it should not be toxic or unacceptable. It should not be unripe. That should be kept in mind. Then harvest maturity should have adequate shelf life. So even after buying at the consumer end also, it has to be in good conditions for about 2 to 3 days at home. Then if you look, there are different types of maturity. The first one is physiological maturity, and second one is horticulture maturity. Physiological maturity, let us understand this. This is the attainment of full development of stage just prior to ripening or ripening in climateric fruits. So it is good for the fruit and vegetable production, for seed production. So if the fruit and vegetable or the horticulture commodity is left to the plant, the plant will allow the fruit or vegetable until certain stage only, until the full development. Thereupon, ripening or the decay will start, even if we leave in the on the plant itself, on the tree or the plant itself. So that stage we call it as physiological maturity. But the case is different in case of horticultural or commercial maturity. It is a stage at which growth and development is optimum. It is not full. Let us understand, this is full, and horticultural maturity or commercial maturity is optimal. It may not reach up to full for specific use, intended for the specific use, especially for consumers or the markets. Then if you look, examples are fresh vegetables used for canning or dehydration. Then it can be divided for local markets as well as distant markets. So further, it can be classified, the horticulture or commercial maturity can be classified into physiologically immature group, then firm and mature group, then harvest ripe group. So you can see the growth and development is optimum. So it is physiologically immature or the unripe fruits are also harvested. So that is what a commercial maturity means. Then firm ripe fruits in some fruits and harvest ripe fruits in some fruits and vegetables. So after ripening also, some of them are harvested. So let us understand in this way. And this is a picture which shows the development of fruit and vegetable. As I've told you, physiological maturity is the growth, nothing but cell division and cell elongation of the fruit or vegetable. Then which is preceded by the maturation. So attainment of, if it is physiological maturity, attainment of full development. Then it is followed by ripening and then senescence. So from initiation of the fruit or the fruit set and then to the decay or the death of the fruit. So these are the different chronological steps which is being followed in the life cycle of a fruit, development of the fruit. Then, but if you look into the commercial maturity or the horticulture maturity, so the stems and leaves can also be harvested in case of asparagus, celery, lettuce, cabbage and all. The inflorescence can also be harvested. So we are not waiting until the fruit development. Here the partially fruits, so they are unripe fruits in case of cucumber and all this. Then the fully developed fruits in case of apple, pear, citrus. Then there are also other underground roots and tubers which are harvested. They are not, we are not concerned about the upper part of the plant. We are concerned about the roots only. So it is not for seed purpose only. For commercial purpose, it is not used. For seed purpose, they are allowed to flower. They are allowed to make seed. The products can be prepared. How to judge this harvest maturity? So now we have seen that different types of maturity based upon the attainment of the full development and also based upon the uses for us, uses for our consumer purpose. We have seen until now. Now we'll know how these harvest, this maturity can be judged. This harvest maturity can be judged in different fruits and vegetables. Most of them are sensory or visual observation. So normal people, not only the growers, can also judge the maturity with the help of the sensory organs. These 5 sensory organs like sight, feel, hear, taste, smell, and then touch. All this comes into picture. And some other methods like subjective methods, which are discussed in the next coming slides. First, if you look at the sight, that is by looking only, by observing the color, size, shape, persistent of the calyx, presence of dried outer leaves, then fullness of the fruit, drying. By looking only, we can tell that this has become mature. So it is ready for harvest. We can judge like that by looking only. Then by touching or by feeling the texture in peas, beans, okra, and examples like examples of vegetables, then hardness or softness, then round or smooth, we can feel and we can tell that this is the right stage for harvest. Then some of them can smell, like jackfruit and mango, they produce more smell when they are ready for harvest. Then taste, this is the destructive method. We can cut the fruit, or we can part of the fruit can be eaten, and then there we can judge the maturity based upon the sweetness, saltness, sourness, and bitterness in different fruits and vegetables. Then based upon we, hearing resonance, by tapping the fruit we can hear when the fruit is whether mature or immature. So some dull sound is observed if you tap the big fruits like watermelon and jackfruit, they are matured. If their ringing sound is observed, then they are immature. Likewise, we can judge them. So normally farmers will go with this type of harvest maturity index for harvesting of their produce. And there are some disadvantages for using these sensory qualities. What are they? When cultivated in large area, these techniques are tedious. So this becomes a bit difficult under large scale. Then the color of the fruit or the bunch cannot be the same due to variation in the perception from person to person. So we cannot judge as such. Then variation in the weather conditions misleads the judging. Some fruits may be matured early within the same orchard or within the same tree also, it differs. So we have to take care of all this. Then variation in the biotic and abiotic structures within an orchard, the microclimate, influence of the crop judgment, like pond, near the pond or composite pits, they grow luxuriously, but other trees and the dry zones and all, they will not put forth good fruit, and the maturity may be also delayed. In that case, sensory maturity, by going by different visual observation, may not fetch much praise to the farmer if we harvest at that stage. As we cannot rely on sensorial methods of harvest for judging the harvest maturity, we also have some important methods for judging the harvest maturity of fruits and vegetables. The first one is computational methods, that is through calendar date, days from full bloom, heat units, T stage. So these are the computational methods. Then we also have another group like by judging with the help of physical methods like fruit retention strength, freeze size, and surface morphology, then weight of the fruit, then specific gravity of the fruit, the color, especially the skin, flesh, and also the seed color can also be, by knowing this, we can also judge the harvest maturity. Then firmness of the fruit, then ease of separation from the plant or the tree, then brittleness of the floral part, then by judging with the help of juice content, then bulk density in case of cole crops or lettuce, then structural properties, whether it is soft or rough, then development of the special layer in case of melons. It is its special reference to melons. Then the other category of methods to judge the harvest maturity are chemical methods or the destructive method. By estimating the titratable acidity, then TSS to acid ratio, then sugar to acid ratio, then via electrical conductance, starch iodine test, then tannin contents, especially in case of dates, persimmon and lychee, then oil content in case of avocado, juice content in citrus fruits. Then the other category is physiological methods. As I have told you before, the rate of respiration, and I've shown you the table also, the different categories of the different classes of the fruits and vegetables, different commodities, based upon the rate of respiration or the rate of ethylene production, they are classified. Then rate of transpiration in case of leafy vegetables, then production of volatiles in some of the fruits. Then the fifth category is through geometrical methods like particle size and shape of the produce, then particle composition and orientation in given tissue or the food, then moisture content of the produce. All these are the some of them are physical methods, destructive methods. Some of them are non-destructive methods. So if we go in detail in judging the harvest maturity, not only by sensorial qualities, one can achieve maximum returns in the market. So let us see the advantages of judging the estimate or estimating the maturity of the harvest maturity. Why should one judge instead of simply harvesting them? In order to keep up the quality of the produce, then to enhance the freshness, appearance, elegance of the produce, then improvement in the storage life of the produce, then management of ripening and senescence. So in order to delay the ripening or hasten the ripening, so all this can be taken care of. Then extended utilization of the produce, then easy of handling during the different operations, then to maximize returns, then to manage the environmental factors, then to manage the pests and diseases during post-harvest, then for long distance transport of the produce. For all these reasons, it is important to judge or estimate the harvest maturity of perishables like fruits and vegetables. So let us go in details with the methods one by one. The first method being the computational methods. It is the calendar date. It is one of the commonly used indices for maturity for judging the accurate time of harvest from flowering to the growing season to the harvest. So the this is reasonably accurate with providing flowering and weather during the growth season is normal. Then standardization requires for many seasons for given locality, location, and rootstock. So example, if you see mango harvesting period, so likewise different fruit crops have different time of the year, that is April to July. So in some fruit crops it is during the monsoon season, some are during the winter season. So likewise we can estimate when we can roughly we can estimate when we can go for harvesting based upon the calendar date. So most of the farmers will rely on this calendar date. Then the price also is more during this. If we harvest them and market them, the price the farmers can fetch more price during the peak seasons. Then the second one is days from full bloom. So it is reliable, but varies greatly from year to year and location to location. In such case, optimum date of harvest can be predicted by doing the night temperature correction. So here you can see for 15 days following full bloom. For every 1 degree Fahrenheit variation from an average night temperature, a correction of 1 day is made in the standard figure from full bloom. So it is by calculating the number of days from full bloom, and a small correction is taken along with the temperature. So for 1 degree Fahrenheit variation, if it increases, we have to minus one day. If the temperature, night temperature decreases by 1 degree Fahrenheit, so we have to increase 1 day. So likewise, if you look for mango, it is around 110 to 125th day after full bloom. We can go for harvesting. In case of it is followed in case of the variety Alfonso and Peri, and banana in case of dwarf Cavendish, it is between somewhere in between 99 to 7 days after full bloom. Then the third method of computational harvest maturity, judging the harvest maturity, is degree days or the heat units. Then it is the optimum maturity that is computed by the sum of mean daily temperature above base temperature, which is 10 degrees centigrade or 50 degrees Fahrenheit. In case of apple, it has been studied for a period concerned. The number of degree days to maturity is determined over the period of several years. So this cannot be taken care of for a single year. It should be read over years. So several years it should be taken care of. Then a correction, 10 degree centigrade or 50 degree Fahrenheit is the temperature at which growth occurs for apple, and the base temperature varies with crop to crop. The degree days is based on growth temperature relation. So it is mainly the temperature, the night and the day temperature, it is concerned. However, the heat units work only with limited temperature. Heat units are not useful for photosensitive species. This is the major drawback. You have to remember this. A heat unit is calculated by daily mean temperature minus base temperature. The base temperature is 10 degrees centigrade. In case of apple, this has been read, but it may differ from a fruit crop to fruit crop into number of days from flowering to harvest. So, likewise, if you see for tomato, it is 15 degrees centigrade, the base temperature. For apple, it is 10 degrees centigrade. So, the daily mean temperature minus base temperature will give you certain number that is further multiplied into the number of days from flowering to harvest. So it gives a heat unit. So as and when the heat units are seen, then we can go for harvesting. Here you can see the degree days. It is calculated for almost the fruit growing season. So here is a table which shows the heat requirement for apple, which is the base temperature is 10 degrees centigrade. In case of red delicious, the base temperature is 18 degrees centigrade, and harvest should be around somewhere 1659 to 1705 degree days. So that is the calculation which we have to do for harvesting of the fruit or judging the harvest maturity. In case of grapes, this is also taken as 10 degrees centigrade base temperature. It is around 1600 to 2000. For Thomson seedless. For Bangalore brew, it is 3562. For Gulabi, it is 3508. And for Banganpalli, it is also 18 degrees centigrade. And the degree days are around 1420 degree days. After as and when the fruit achieves this number, then that is the day one have to go for harvest maturity. Likewise, we have in banana, asparagus, peas, and some of the fruits and vegetables. So these are difficult when compared to other methods, but the destructive methods are more easy and fast for judging the harvest maturity, upon which the physical methods are, first one is the fruit from the tree, which indicates the maturity strength. So if you are pulling it very easily, so that is the place. So the abscission layer is formed. Thereby, we can easily pull off the tree. So the tree itself shows that it is fully matured. Then we can go for harvest. So if you look, the mature fruits requires more to detach from the plant. Then the second one is sound test or acoustics test. Then when we tap with the finger, so the sound testing of the fruit, when it is ready for harvest, it shows a dull sound in case of watermelon. So even for purchasing also, the consumer will go for this type of tests. Then based upon the skin color, this is the important method of judging the harvest maturity for most of the growers. This is a common method when fruits for judging maturity, where the skin color changes as when the fruit matures to ripe. Then if we look, in most of the fruits are green in color during the unripe stage or the mature stage. As and when they started ripening, they started showing reducing the green color, light green, then changing to yellow, in some cases to red, purple, and violet during optimum maturity. It's still green, we cannot harvest. When they start showing a degradation of the green color or the chlorophyll, then it is the best stage to harvest them. Here you can see this based upon the color. So the banana hand, you can see it is all green in color. Then green with a trace of yellow. Then green, more green than yellow. If you look, more yellow than green, this is the next stage. Then yellow with a trace of green. Then all yellow. Then yellow with speckles, brown speckles. So this is a different stages of maturation of the banana. So upon which the firm ripe stage, that is all green stage, this is used for export purpose, and for local purpose we can go for more yellow than green purpose. And this is the stage where some consumers prefer buying, and full yellow without any speckles, some consumers will prefer for buying. Then likewise, we also have mango based upon the color judging maturity. Then tomato, we have a green stage, breaker stage, turning stage, pink stage, light red stage, and full red stage. So this is the judging of color human eye can judge the color, but even then, with the help of the colorimeter, it is the instrument which measures the color exactly. So this is used for research and development purposes for judging the harvest maturity. Then the other physical method of judging the harvest maturity, the shape of the fruit. So shape is referred to the design of the fruit. Then it can be changed during maturation and ripening. If you see banana, in case of banana, the individual fingers are rounded when they are mature. But however, if they're immature, they are angular in shape. So we can notice the different angles. But if it is ripe, it is almost round in shape. In case of mango also, the immature fruits slope away from the fruit stalk. As and when it becomes full or the mature stage, the shoulders of the fruit will be visible more. These are the shoulders will be visible more during the harvest stage or the ripening stage, or the fullness of the cheeks we call them as, or the shoulders of the cheeks we can call in case of mango. Then, according to the size is one of the maturity index for judging maturity or ripening in case of fruits and vegetables. Then, when they attain full stage, we can easily say that it is the right stage of maturity. In case of lychee, beans, okra, asparagus, potato, this directly it is related to the size. Then banana, individual fingers. Then in case of baby corn, immature smaller corn are marked for maturity. Then the other one is we already know. We have seen the sensory qualities. Then the other method of judging fruit maturity is fruit opening. This is in case of fruit spices like nutmeg, actree, and vegetables like chocho. The distal end of the fruit opens and large seeds emerges and germinates. So this is not usually followed for commercial method of harvest maturity. In case of most of the fruits and vegetables, it is for some restricted to some fruits. Then abscission layer. So the pedicel, before we have seen ease of separation from the trees. Especially in case of melons, it is best method for judging the harvest maturity. Then the specific gravity. This is also one of the most important method of judging harvest maturity. So if you put the fruits in the water, and a bucket full of water, and the fruits which are immature will have around 1 to 1.015 specific gravity, and they float on in the water. When the fruit is mature and ready to harvest, they sink down to the bucket of water, which have around more than one, that is 1.02 specific gravity. Then the firmness is also judged for harvest maturity of fruits and vegetables. If we press a little bit like cabbage and lettuce with a thumb and finger, if they are loose, then it is the best method for harvesting. Then if you look in case of other fruits, the changes in texture during maturation and ripening, excessive moisture loss, and the texture can be reduced. The firmness is reduced in case of most of the fruits, and at that firm ripe stage only we have to harvest them. Then the texture changes. So some of the destructive methods of judging the maturity are also there, like penetrometer or the pressure tests. Here we have a pressure tester, which has a mechanical value of the texture, which give the value until the critical stage. Then that is the stage when they are harvested. Like the tenderometer, which is especially in case of peas. You can also expect some of the examples with this harvest maturity indices. Peas tenderometer is used to judge its harvest maturity, to judge the tenderness of the peas. As and when the piece mature, the sugars, the starch is converted into sugars, which coincides the ripening of the or the maturation of the pod. So in this case, a particular tenderometer is used. Then the other chemical methods are the destructive methods for judging the harvest maturity. This first one is the juice content. So it is useful for most of the citrus fruits. So if the content is here, you can see different citrus group like oranges, grapefruits, lemons, and mandarins. So more than 30% juice recovery is used for judging the harvest maturity. As and when they achieve this value, then it is the best stage for harvest. Then likewise, the oil content in case of avocado. It should be not less than 8%. If it is less than 8%, so that is not the right stage. We have to wait until it reaches to that stage. Then only we can go for harvesting. Then the dry matter content. So rate of dry matter accumulation is used to predict the optimum stage of harvest by using the instrument hydrometer. So hydrometer is also used. In case of potato, it is useful for judging the dry matter at the time of harvest. Should be within a range of 18 to 24. And then the sugar content. So in climatic fruits, the carbohydrates are accumulated during maturation in the form of starch. As and when the fruit starts ripening, if they are broken down into sugars, as I have told you before. In case of non-climatic fruits, sugars tend to accumulate during maturation only. So we can judge by a destructive method by taking the juice sample and then reading it in the Briggs hydrometer or refractometer. So it should be around the apple should be around 11 to 14, 11.5 to 14.5, then citrus 12 to 14, then grapes it should be as near as 20%, likewise. So these are the different values of the TSS as and when they reach the fruit reach at that stage, then it is the best stage for harvest. Then acidity can also be judged in many fruits. Then the extraction of the juice. This is also a destructive method of judging the harvest maturity. The juice is titrated against a standard alkaline solution to measure the acidity percentage. So even before we have seen the TSS in case of percentage and acidity also in case of percentage, and the ratio of this is helpful for judging the harvest maturity in most of the fruits and vegetables. And this is the table which shows the different methods of maturity indices. This has been deeply discussed, but in a tabular form. In order to remember, it is easy for you to remember in a tabular form. Please remember some of the important examples, at least one or two examples for most of the maturity indices. So visual or color charts is useful for most of the fruits and vegetables. Then calendar date also. Then days from flowering to full bloom is most of the fruit crops and some root crops also. Then heat units is also useful for most of the temperate fruit crops like apple, pear, grape, and some tropical and subtropical fruit crops. Then tea stage is more. This is one important method for apple. So the even apple also shows the rise of the shoulders when it is matured, but it is normal. So this is the pedicel and this is the stalk. So if it reaches fully, then we can tell that it is ready for harvest. That is called tea stage. It is not covered before. That is the reason I am telling now. Then the size of the fruit in almost all fruits and vegetables. Then surface morphology, like in some examples like grape, in some fruits like the cuticle formation or the small powdery growth is being observed when the fruits are mature. And banana, sometimes mango, lychee, sapota, all this are some fruits are more glossy and some fruits are more matty in surface. By looking on this all also, we can judge the maturity. Then specific gravity sinkers and floaters for almost all the fruits. Then fruit retention strength, apple, almost all the fruits. Then color of the surface or the rind, then seed and flesh. So and sometimes the instrument also is used, colorimeter. Then leaf changes. If underground, most of the underground vegetables, root vegetables, or bulk crops, so the leaf changes on the top can also be observed. Then textural properties like firmness. Then tests are also done, like piece tentrometer. Then uh, finger squeezing in case of okra, beans and potato, peas. Then shape of the fruit, compactness in cabbage. That is what the thumb. We press the thumb into the cabbage. If it is compact, then it is the best stage. If it is loose, that is not going to fetch big price in the market. So cold crops it is best. Then angularity in case of banana. Then shoulder development in case of mango. Then abscission layer in case of melons. This is also one important bit. Then bulk density in case of cold crops. Then if you see in the flowers, tight bud stage or the bud crack stage or the full flowering stage. These are the three stages at which the flower crops are being harvested. In case of rose, many flowers, cut flowers, and full opening in case of loose flowers like marigold, chrysanthemum, and all. Then the internal factors like total soluble solids, dry weight, then starch added test in some fruits. Then acidity percentage or the sugar acid ratio, then juice content astringency in case of the tannin stringency in case of persimmon as well as dates, that is also important. Then the oil content in case of avocado, juice content in most of the citrus species. And based upon the physiological methods of judging the estimation, most of the fruits and vegetables they're judged according to the rate of respiration and rate of ethylene evolution, and thereby we can divide the fruits into climatic and non-climatic fruits. So this is also good for judging the maturity. Then optical methods. In case of apricot, banana, orange, and papaya, then aroma most of the fruits like mango. Then fruit opening, it is not that important, but it is followed in case of nutmeg and chocho. Then acoustic or vibration melons, then electrical characteristics. So peach will show 550 hertz. When it is unripe, then if it is ripe, it shows 150 hertz. Then electromagnetic NMR, nuclear magnetic resonance in case of apple, banana, avocado, peach, pear. Then infrared reflectance. So these are the some of the non-destructive methods by using electromagnetic waves, electric waves, then infrared waves. So these are also used for judging the harvest maturity. In case of mango and pineapple, so it should be somewhere around 400 to 2500 nanometers. And then radiations like X-rays, gamma rays, all these are used. Lettuce, root crops, lettuce, potatoes. They're also useful for enhancing the shelf life of the tubers also. This exposed to X-rays or gamma rays. So they can even help to judge the maturity. So these are the different methods for judging the maturity, harvest maturity in case of fruits and vegetables. Thank you.